Once I start talking about math, I don't remember anything. How lazy do I want to be? All right, get up. All right.
Also, your background's totally still on, so we can't see what you're doing.
Oh, that's fine. You'll never know what I had up here. Let's see. Do I still have Jupyter up there? Yeah, it's a pretty good size whiteboard if I use Jupyter. All right, let me turn Jupyter off. That's a neat phrase to be able to say. Okay. Let me see. So real quick. This is actually a really, I don't want to get too deep into what the meaning behind this is. So let's create like, okay, let's say h of x is 4x minus x squared. And then it asks me to evaluate h of x minus h of a over x minus a. I don't know if anybody realizes this. This is all I'm going to say about this because you don't even have to realize this, but this is y2 minus y1 over x2 minus x1. This is slope. That's all that really is. Do you need to know that? No, you don't. But this is going to become huge in calculus. Huge. All right. I know what h of x is, so I'm going to put that there. But what is h of a? What is ha? What would h of a be?
4a minus a squared.
That's all it is, right? What would h of b be? Just out of curiosity, what's h of b?
4b minus b squared.
Does everybody get me? I like it. The process is not defined based on what's in here, is it? The process just says whatever's here, I put it here and here. That's what the process says. That's what does everybody sort of get what I'm saying? So if I put a fraction there, do I change what? No, I put it there and there. All right, all right. So I know this is h of a. Now, here's the thing you got to be careful about. So I want to evaluate this expression. So I'm going to put h of x here. Now here's the mistake people make. This is a mistake. I want to subtract h of a. There, now I'm subtracting h of a. Before I was subtracting a piece of h of a. So people forget these parentheses here. All right. And then believe it or not, this will factor. Believe it or not. I'm not joking. So what I would do is I would rearrange this a little bit. So let me work this way. I'm going to rearrange this a little bit. 4x minus 4a minus x squared. Let me see if you guys are cool with this, right? Man, is that the best way to do this? Yes. Yes, okay. Let me stop for a minute. Is there See what I mean by this is a construction problem. I need this. Okay, got it. I need this. Oh, let me construct that. Okay, now I've constructed it. I can put it there. Bam. And now I can evaluate this. Are you guys doing okay out there? Don't worry, Nicole. I'll get to your question in a minute. Sorry. Didn't mean to call you up. Are you guys okay? Are you guys? It's okay if the answer to that is no. I just need to know the answer. Did I lose somebody? Did I lose somebody? Tell me where I lost you. Am I still coming through? Is my Wi-Fi okay? Is this thing on? Okay. All right. Some of you guys, my goal is to make some of you guys smile a little bit. And you're like, dude, we're in math class. What are you going to do about that? Tang, what's up?
Oh, I just misclicked. Sorry.
Oh, you accidentally did that? Okay.
Yeah.
I'm going to take it away. Bam. All right. Now this is neat. This is going to help you guys with the problem you have to do. Can't I take a 4 out of here? Let me see you guys understand this. Isn't this minus x squared minus a squared? I would love this problem when do you see how I can factor this now? That's a difference of squares there. So this is this thing in the way? This is the kind of problem that you need to just be able to sink your teeth into, the type of math. So if I want to finish this up, I left myself like no room. Let me take this up here. So I got 4x minus a, gather, minus x minus a, x plus a, all over x minus a. I can take an x minus a out. I don't know if you guys see that. When I be done with 4 and then minus x minus a. Well, a lot of good shit happened there, and there's your answer. All right. Not your everyday kind of stuff, but that's the class we're in. Every step I did was not difficult. This step is probably forgetting these sucks, understanding you have to rearrange things, and then understanding that that is actually a difference of squares. Okay. There are other ways to do that problem, but that's the most direct way to do that problem. And again, that's not exactly the problem, but it's close enough to what you got to do in number 33. All right, so somebody, what do you mean you can't access the 3-1 homework? I'm sorry, I'm going to call you out. What do you mean?
Can you hear me?
I can't.
Okay, so when I click on it, it won't show me what I have to do or nothing. Like it just.
Oh, okay. All right. All right. Wait up. Hold on. So does everyone else, sorry, I feel a little feisty today. Does everyone understand what the homework is? That the 1-1 and 2-1 was
I just went
special.
to the, yeah, I went to the chapter 1 review and then I went to section 3.1.
I don't know what you mean by that. I
Like to
think you
get to
mean,
the
do you mean
problems.
where the assignment is, Nicole, or do you mean where the?
So when I go to modules and I click on the 3.1,
Sure.
and I've done everything before.
Because I gave you
Oh,
copies of the thing from the book, right?
okay.
So-
And then for the textbook, I'm having trouble sometimes trying to find it in the textbook. So.
It's always
How
at the
would I-
end of the section. So wait, I've already got the textbook
Oh,
open.
okay.
Let me stop sharing. Let me see if I can make this work. All right. So I'm in section 3.1 right now, right? You go to 3.1 and you just, and so you open up 3.1, right? You open up, you go to 3.1,
Okay.
and then you just all the way down. And then you're in the homework. I mean, there's,
Okay.
you can't help but get to it.
All right. That
Yeah.
works. Thanks.
Sweet. No, I don't know if you access it this way, or did you download the PDF or something, or do you access it this way?
Now I'm frozen.
Uh-oh. Or am I
froze.
frozen?
Can you hear me?
I can.
I was frozen for a second. Yeah, I don't know what I was doing, but now I know what to do.
Okay, all good. Let me see. Is it not 4 minus x plus a? No, definitely not, because this negative goes through. So you take the x minus a out, and then that negative goes through. Is that cool? So many little things in that problem. I love it. You just have to not rush. Now, I understand on that problem, you're like, I couldn't rush because I didn't even know how to start the damn thing. So I was going really slow, Jeff. And I said, all right, I understand. And that's why I'm here. I'm here for you to ask questions. Anything else, guys, before we jump back into where we left off? I graded a lot because a lot of people turn things in Very recently. So I graded some stuff right up until class started. I was grading. So I'm going to just keep grading after that because what's happening tomorrow? Does anyone know? Quiz. Holy shit. So let's talk a second about how that's going to work. And everybody is aware of that, right? Before he even said that, because on the homework sheet, you got all the quizzes when they're going to happen. Okay. So I'll tell you this much. And then tomorrow we'll go over some more details because I'll have the quiz actually built into the Canvas. Maybe I'll put I don't know what I'll do. We'll find out tomorrow. The quiz is not going to happen during class. It's going to open after class. And then you're going to have, until right before the class the next day, you're going to have to do it. And the minute you open it, it's timed. I might give you, I don't know. I'll figure it out. I'll see what I'm feeling like. I haven't figured out yet when exactly I'll make it due. If I make it due right before class, then hopefully everybody understands I probably won't get them all graded. But if I give you a little bit more time, we'll see. I'll see. Anything else about the quiz tomorrow? That's how that's going to work. It will be in Canvas. The way Canvas is, I don't know how much I want to say now. I think I'll just talk about it tomorrow because I'll have something built in Canvas I can show you. It's a little weird how I have to make it work. Okay. So when you have a quiz, I'll say this again tomorrow, but when you have a timed thing, I don't know yet. It depends on how long it ends up being, Julius. When you have a timed thing and you have technical difficulties and the time is running out, you email it to me. If your Wi-Fi goes down and you're about to email me, you're about to send it in, we're going to have to figure that out. It depends on how long it is after the due time. Does that sort of make sense? I mean, it's going to have to be, if something happens, we just have to do a case-by-case basis. But if your Wi-Fi is not down, but Canvas won't accept it, then you just email it to me and then keep trying to upload it so that I have a record of when you were done. Does that make sense? It'll be a time thing. Okay. All right. We don't know. So the only things you have to be on Zoom for with the camera on is the midterm and the final. So there are 2 times during the semester that I am legally allowed to make you have your camera on. Nah. If that is for some reason impossible, you're going to have to get in touch with me somehow and we have to work something else out. But yeah. Anything else, guys, before I jump back into where we left off? Any other questions from chapter 1, chapter 2? I think we did section, let's see, where did we leave off? We did 3.1 and 3.2 basically on Thursday. I think we'll start off with some more piecewise functions, right? Piecewise functions. And then I need to tell you, if I give you the function, how do you tell what the domain is? So we'll do a few of those. All right, so if there's no questions, we're going to just do a piecewise function to start off with. We'll talk about domain a little bit, and then we'll get into section 3.3. Crazy. Okay. Let me see. You're up in my business. Get back. All right. Move my chair over. All right. So let's try out another piecewise. I think that's the last thing we did Thursday. If I do this way, is that the right way? Yeah. Okay. All right. So all right, I didn't want to jinx anything, but that's like that is bad, but it's like the best writing for me for a long time. Okay, sorry, I just have to celebrate small victories. So what if I gave you this one? What do you got, Joe? I don't know. Oh, let's see. What do you got over here, buddy? I like it. what's it going to look like for inputs less than 1? What will the shape be? Inputs less than 1, what will the shape be?
A line.
A line. There, see? That's all you needed to say. I like some of you guys are like, I don't know what this guy wants me to say. For inputs greater than or equal to 1. Somebody else, what will the shape be?
Parabola.
Yes, parabola or a parabola, however you're feeling. What is the approach I said you could take? What is, especially if you're not feeling that comfortable with these, you can create a table of values for each one. Let's see who remembers. What value can I not use? What's the first value? How do I want to say this? What is the most important point for this piecewise function in a sense? Can anyone identify the most important input?
1.
1, good. So am I allowed to use 1 for this piece of the function?
No.
No, I'm still going to though, because I'm crazy. Does anyone remember what I'm going to do when I do that?
Circle. The point.
Yeah. Parentheses. Yeah.
I like it. And I do that. I made that shit up. I'm not claiming, I'm like, ooh, look at me, I'm amazing. I just did that so to remind myself that that's where the open circle goes. I'm not allowed to use 1. So what would I get if I put a 1 here?
1.
1, crazy. So there's going to be an open circle at 1, 1. This looks like, oh my God. And then you just, now what else can I put in there? What's the next smart thing to put in there for this guy?
0.
0, I love it. When you get a 0, you get 2. When you put a -1, you get 3. Okay, that's enough. We know it's a line. That's all I need. So what I'm going to do for x squared plus 1, I'm going to start probably at what?
1.
1. Am I going to have to put parentheses around it?
Nope.
No, because I'm allowed to use it, right? It's allowed to equal 1. So when I put a 1 in, I get 2. Is that cool? When I put a 2 in, I get 5. When I put a 3 in, I get 10. Whoop-de-doo. Is that all right? This is basically what you do whenever you are facing something to graph that you're not comfortable with. You go back to ultra basics, make a table. That's the most basic you can get with graphing, is making a table, right? So if we're not very comfortable with this weird thing, let me make a table. And now I can graph. So let's see. Oh, let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. Is that going to be good enough? Uh-oh. 1, 2, 3, 4. That'll be fine. Okay. So 1, 1, I'm going to put an open circle. Open. 0, 2 is good. -1, 3 is good. So there's my line, and it goes forever that way because it's less than 1. So it's forever that way, less than 1. Now here, 1, 2, 2, 5, 3, 10 would be where they held there. Who cares? And then it's parabolic. There you go. Let me see what your gut tells you about this. This isn't part of our class, but I just want to ask you, is this whole thing continuous? Do you think that this represents something that is continuous? Like, is this a continuous line? Is that continuous? Yes. Is this continuous?
No.
No, because it jumps. So is this continuous, this function?
No.
Nope, it's got what's called a jump discontinuity. I like it. That's something you'll learn about in calculus, but that's all it really is. There's all kinds of discontinuities, but that's a nice one. That's a jump. Yeah, it just jumps out of the way. Okay, I like it.
Oh, Professor,
Yes.
it has nothing to do with this part of the class, but the syllabus with all the list of all the homework and the quizzes, I still can't see it.
All right. This is not a great time to bring that up. Maybe after class, just hang out.
Okay, sorry.
That's all right. And I will do a practice midterm and a practice final, but there really isn't a practice quiz. Nope. If you want more practice, you can do the problems from chapter 1 and chapter 2 that I did not assign, right? To help you out. Yeah. Okay. Oh yeah. So I was gonna say something about Dragon Balls, like instant transmission, but that's a little too geeky. All right. All right. Now.
I'd say it's pretty appropriate though.
Oh, thank you. Right. I have a couple of areas where I like to use Dragon Ball. Okay. Is that cool with everybody? I mean, that's how piecewise functions work. You know you've made a mistake if they give you a piecewise function. How do I know this person made a mistake? Well, there's a couple reasons, but why is that definitely a mistake? Is that a function? Is that a function?
No.
Why not?
Vertical line test.
Vertical line test is failed in many places. Yeah, so that's the biggest problem is people just kind of make a full parabola and they make a full line. I'm like, no, that's not a function. So you got to pay attention to the part where it says x greater than 2 and x less than or equal to 2. That is where one stops and the other one takes over so that there is no overlap. Otherwise, you have something that's not a function. So how could it be a piecewise function? Okay, so there's no overlap here, right? Nope. It's not here, it's there. So every vertical line goes through once. I like it. Okay, okay. Maybe. So let me ask you this. Here's something you should know. What is the domain of this? We talked about how to get domains from graphs. The little dude walking on the axes, remember that? Little dude walking on the x-axis, the y-axis. What is this guy's domain? That's not a graph. Don't graph this thing. Dear Lord.
If it's on the bottom, just set the bottom to 0.
I like it because the idea of domain. Wow. Okay. Sorry. You're having a few Wi-Fi problems. I shouldn't laugh. I'm sorry, because it's rough to be on the side of it. You're coming through a little.
Me?
Yeah, you're coming through a little.
Oh no.
It's okay. It's okay.
I'm a robot. I'm sorry.
We all know now. You can't hide. We're all jealous, actually. So domain means all the x's that have an output. This kind of function cannot have an output if the bottom is 0. So you say to yourself, in English, you say to yourself, what's the issue with this? The bottom cannot be 0. And then you write that in Mathish. So what can x not be?
3.
3. So if you want to be really hyper-technical, it would be negative infinity to 3 and then start over again 3 to infinity. So that would skip 3. So that would be the domain. I like it. And now, so you guys do this one. I don't have any room. I wish I could remember to do room. 3x over x squared minus 11x plus 24. Right, I'll make it something easy. Same question.
So would you factor the bottom to equal 0?
Good. So you want the bottom can't be 0. So then you have to factor that bad boy. What do you get?
7 and 3, negative 7 and negative 3.
No, because that makes 21 and 10. This is
Oh,
24,
yes.
right? Okay.
Negative 8. Yeah, negative 3.
I like it.
No, I mean,
Sorry?
no, nothing.
Okay. So then x cannot be what?
8 or 3.
8 or 3. So then the domain, the domain of this, technically, so this is fine. That's the domain. X cannot be 8 or 3. If you want to get really technical, negative infinity to get out of there, 8 to 3, union with 3 to 8, union with 8 to infinity. So negative infinity, skip 3, skip 8, go to infinity. That's how I read that real quick. If you want to be hyper technical. Hyper technical. Okay. All right. So what about this? So why were 1 and 2 so similar? Because the type of function we were looking at was the same. It was a ratio. It was a fraction function. So it had the same idea. So what about this? What's the domain of this? Make sure you guys can read that. Hold on. Why are you so shaky, dude? Shaky. All right. How the shit would you find this guy's domain? Can you tell me in English what the issue is with this guy? And when I say domain, I'm talking about real numbers. If I wanted to talk about over the complex numbers, I would have to say
Plus or minus?
no.
It's a square root, so you have to square it.
It can be a
No.
negative
Is
number.
that what you would do?
No, I'm not solving an equation here, so I can't do that. If I square both sides, I get h squared. What the hell's that?
You can put a negative number in a
Yes,
root.
so the inside, what must be true about the number inside to keep it real? What must be true? What number can you put inside of a square root to keep it real?
Positive.
A positive number?
Or
Zero.
0. So what's a better way to say it? The inside must be at least 0. I really want you guys to get this. If you just say in English, what's the restriction? The bottom can't be 0, and then you write the mathish. The inside is at least 0. What's the inside? 7 minus 3x. How do you write at least? At least. 0, 0. Solve. That's so beautiful. What x values force this to become a non-negative number. Then the square root stays real. So now solve this. And then you get your domain, right? So if you'll eventually get x less than or equal to 7/3. How you guys doing out there? You guys all right? You guys all right? What can you do this with, Jeff? What functions can you use this idea with? All of them. Every single function. You say to yourself, what is the restriction? Can I write that in mathish? If you can, solve that thing. So this guy's domain would be negative infinity up to 7/3 bracket. Woohoo! What does that mean? Those are the numbers I can use to make this stay real. Those are the numbers I can use to make this stay defined, right? All right. The few faces I can see look confused, but nobody's asking questions. Okay. All right. What about this dude? Oh shit, well, let's just go back to F. What's different here?
Cube root.
Cube root. Do cube roots have any hangups like square roots do?
No.
Nope. Cube roots are so laid back. Oh, yeah, negative? All right, the answer's going to be negative. You're positive, zeros, no problem. So who knows what the domain of this is then if there's no hangups? There's no restriction. What would the domain be?
Would it be all real numbers?
Kick ass. You could say all reals, check. You could say R with another spine. Do you guys know that symbol? That's the symbol for all real numbers. You could say negative infinity to infinity. There's nothing you cannot use there. No real number you can't use in a cube root. All right. So that's how to find the domain if they give you a function. We did last time how to get the domain if they give you a graph. We did that. All right. So today, the new stuff we're doing, well, that was new stuff, I guess. So we just finished section 3.2. We're going to get into section 3.3. And I'm going to do something, let's see. Let's say that, all right, Jeff, you could do it. Let's say there's this thing. And let's say at the beginning, at t equals 0, time equals 0, I'm sitting at 5. For some reason, I think of this as a car, the Pope Mobile with his bulletproof thingamajig. So at t equals 0, I'm at position 5. So you're going to love this. F of 0 equals 5, right? So at time 0, I'm sitting at 5, let's say meters. Let's say this is seconds. At t equal to 4 seconds, I am now sitting at 10 meters. Right, and my car I hit a few bumps. So one of my wheels has come loose and I'm about to fly off, but we'll be okay. Can somebody tell me what the average velocity is for that little tiny 4-second trip? So I like this idea because I'm hoping this is simpler than, well, we'll find out. We'll find out. How far did I go?
5 meters.
5 meters. How long did it take me to go that far?
4 seconds.
So I got 5, Jeff, you say 5 and you write 4. 5/4 of a meter per second. Nothing major there, right? What did I do? I did how far I went divided by how long it took me. I like it. Now, here's what I want you to understand. At 0 seconds, I'm here, right? At 4 seconds, I'm there. What did I do in the middle? Did I go at a constant speed? Did I always go in that direction? I don't care. It doesn't matter. I really want you to understand. The average velocity from here to here depends on how far you went, how long it took. Okay. In the middle here, I could have sped up, I could have stopped, I could have whatever. It's only 4 seconds, but whatever. All right. So we're not going to see a problem like this necessarily. Here's what we're going to see. And what we're doing here is average rate of change. Just this is a great place to start because we're used to velocity. We know what velocity is. But what is velocity in terms of average rate of change? What is velocity the average rate of change in? Average rate of change of what?
Distance and time.
I like it. The average rate of change of distance over time. I love it. Okay. Ooh, what to do? Now, here's another way they could give me a problem like this. I want to know the average rate of change of the function over the interval. What do you got, Jeff? Yeah, that's your 2 to 4. So again, this doesn't have to represent time and distance. This could be, what do you got, Jeff? You could do it. Shoes and age, or I don't know where that came from. Hot dogs eaten in hours. It could be whatever, right? Number of golf balls found and number of beers I've drank. I don't know, right? Okay, strange. So it seems like I drink a lot and I find a lot of golf balls. Here's the technical thing. This is exactly what you guys just did with the car. You just didn't realize it. Actually, let me do it this way. How would I do this? The idea of average rate of change does not change. The idea doesn't change. How much did f of x change from 2 to 4? How much did the function change?
By
How much
30.
did the, sorry, say, yeah, so 49 minus 11, right? Is that cool? 49 minus 11, it changed by that much. Divided by how much did the x's change over that time? 4 minus 2. Aren't we just finding, do you guys understand what's happening? What is it we're actually finding mathematically? What are we doing here? This is something I said earlier in a slightly different context.
The range
y2
over
minus
the domain.
Sorry?
Is it the range over the domain?
No.
Oh, you were going to say the slope.
Yes, you got it. Because I don't care about 5, but that is element of the range, right? I don't care about 12. I don't care about 1. I don't care about 3. It's change in y divided by change. In fact, change in the function divided by change in x. That's the slope. The slope between those 2 points that they give me. So the average rate of change function, all right. So in general, and then I almost don't care what this is. What is this? 38 divided by 2, so 19. Whoop-de-doo. No matter how they give it to you, the average rate of change of a function from, let's say, over, I forget how the book says this, but oh, well, too bad for me. Over A to B is f of B, f of A over B minus A. This might not be the same way the book gives it to you. That might have f of x1 and x, who cares? It's the same thing, right? How much did the outputs change divided by how much did the inputs change? If this is distance and this is time, we end up with velocity, of course, because it's distance per time is miles per hour or meters per second. That's velocity, right? But that's just one example of a type of average rate of change is velocity. Okay. All right, so how else can they? So they can give it to you in table form, but they have to tell you this, what range of inputs they're interested in. They can give it to you graphically, of course, right? So, I'm gonna erase this, here we go. I really want you to understand graphically and table form are the same damn thing. All right, let me see. I got to make something you can read things from. That's always exciting. Let me make some specific things here. Okay. So what is the average rate of change? Let's say this is the h of x function. Oh my God. Of h of x over what, Jeff? -2 to 2. All right, just take a minute and think about it. Hopefully everybody can see where those circles are trying to be, right? That one's easy. Let me see, does that look like it's supposed to be there? Yeah. Okay.
Well, can you wrap it up, bro? I'm trying to pinch a loaf, like dead ass. Also, Victoria, I need that snap.
All right, where the flippin' hell that was is gone. What the shit was that all about?
Did we just get Zoom bombed?
A little bit, but it was kind of a
Right after we heard about it.
it was a pathetic, it was a really pathetic bomb. I mean, that was a pathetic. All right, let me report this dude real quick. Do. I mean, my God, you got a Zoom bomb. You put some effort into it. Pinch a loaf? What the shit? All right, sorry guys. It was pretty sad. As somebody doesn't have much of a life. All right. Man, compared to what some of my colleagues have gone through, I feel really bad. I'm not hoping for a bad Zoom bomb, but yeah, we're just trying to learn some math. Good point. Let me make sure. All right, I guess I'm hopefully not going to have to suddenly start really cranking down on security. Everybody else looks like you belong here. Yeah, I'm going to look at the report after this. So while this is here, this is something I need to remember that I need to make a normal part of class. There is a button on here that will just clamp the meeting down. I'm not entirely certain what it would look like from your side. I think all the videos would go dark. I think you would still be connected because I can just lock the meeting down and then move questionable people to a waiting room at least, and then reopen the class. So if that ever happens, don't leave, just wait. Does that make sense? This was pretty cool because he had his video on and I could tell who was talking. So he was easy to just click on and get the hell out of here. Anyway, all right.
And it's recorded.
Yeah, yeah. So considering that how the school is about, if we got some information from this guy, he could be in huge trouble, which is really dumb. I mean, some of the stuff the Zoom bombings FBI is curious about. So he's in big trouble if we got his information. Okay. So let me give it, oh, we're doing this problem. What do you guys think about this? The bottom should, sorry, go ahead.
Is it 1?
I don't know. I haven't done it yet. Let's see. So if I just write down the idea, this will be h of 2 minus h of -2 divided by 2 minus -2. Let me stop for a minute. Is everybody cool with that? That is the idea. So where I end up minus where I began is basically the idea. And again, it's just y2 minus y1 over x2 minus x1. What is h of 2?
-2.
No, does it really look that bad? I try to make it here, but maybe it's, I didn't even really label this, but
It did look like 2 and 2
I'm sorry.
for each of the dots.
You got to understand from my perspective, it's like that, but I see. All right. Ah, shit and a half. Well, all right. So it's at -1. So let's see. So that's -1 minus, what's h of -2?
I was just looking at the wrong one, actually.
Oh, okay. Thank God. I didn't think I was that far off, but I was a little off. This one is what? -2.
Oh, I'm sorry. You totally can't hear my cat.
I can't. Were you just wondering why I was doing
I
that?
just forgot to. I forgot to unmute. He's just really mad. Don't worry about it.
Understand. That's like default mode for most cats, right? Then 2 plus 2 on the bottom, right? So that's 4. So it looks like I get -1 plus 2. I get 1/4. Is that cool? And look at how this makes sense. If I connect these, doesn't it look like a very small slope? Very small slope. So visually, that's all this does is it finds this. And the slope is an average rate of change. It's change in y divided by change in x. All right. And that, of course, is one of the first things you really overanalyze in calculus. By the way, in calculus, you're going to be able to figure out the slope of something curvy at every point. Do you see how the slope keeps changing? It's positive, and then it's 0, and then it's negative. So that's one of the first things you learn in calculus is, how do I figure out the slope of something that's not a straight line? Which really kind of blows your mind. All right. Let's see. What was the last way to do this? I've lost my train of thought now. Oh, yeah, we already did that way. All right, I did those out of order, which is beautiful. No, I didn't. That's right. I haven't done that yet. Okay. So the last way we could ask this kind of question, one way is I give you a table. Another way is I give you a graph, which is basically the same as a table, just a representation of the answers. And the last way is if I just give you a function. So if I said, find, who just came in? Now I'm on edge about everybody. Oh, well, we'll see if something happens. I don't see anybody that looks freaky. Okay. Everybody take a second. Make sure you've got your last name down. Like Paul, what's your last name? Put that in there. Is that Solanke? I probably said that completely wrong. I'm sorry. Solanke. Paul, are you out there? Paul. All right. Logged in and went back to bed. I understand. All right. So if I said find the average rate of change g of x, they could say over -1 to 3, and I give you g of x equals, what do you got, Jeff? 2x squared plus 1. Do it. I'll wait.
Would you plug them in and
Yeah, try
figure
it
it out?
Yes, try it out.
Also, you didn't answer my question in the chat earlier about the piecewise
Sure.
function. Just making sure that they can only exist if they don't overlap, right? Because it can only be a function if there's not.
Exactly. If they overlap, then it's not truly a piecewise function. It's still a piecewise relation, but it's not a piecewise function. Does that make sense?
Yeah, okay.
Okay. And we don't normally look at piecewise relations, really. We want things to be in one place at a time normally, and most of the stuff we do. Can't get that out of my head. That was just so stupid. So again, the idea here would be g of where I end up minus g of where I start, and then the difference in the inputs. So you can think of this is how many steps I take, and this is how much I changed over those steps. So that's the idea. And it's just slope. So now that you know it's just slope, it's easy, hopefully. So what's g of 3?
19.
19. And g of -1?
3.
This is nice. I wish I could take credit for this. 3 plus 1 is 4. So 16 divided by 4 is 4. Yeah, that's nice. So get it out of your head about what this looks like, the shape of this. I don't care what this looks like. I don't care what it's doing in between the points that I'm talking about. All I care about, well, this would be more like that. All I care about is how much did it change between those 2 points. It's like as the crow flies kind of thing. Okay, maybe. Okay, all right. All right. Now, so that's not that difficult. That's beautiful. That's an old idea. That's slope. I love it. This next thing is going to be very visual. So I think I'm going to go to the book to use some, instead of me trying to draw a bunch of graphs, especially with my scale being so bad. So let me see. I'm still a little on edge about that. It was dumb, but it pisses me off. All right. Rawr. Teachers are very protective of their classes. I'm very territorial. Okay. Let me find a good picture here. Blah, 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 blah. Yeah. All right, here we go. Here we go. Perfect. So look at this bad boy here. Actually, hold on. Let me change screens. Okay. There we go. Put that up there. Are you turned on? Maybe? No? Damn it. All right. I've been having technical difficulties.
Bluetooth connect.
Hey, it's been exciting. Can somebody to say something real quick? See if my speakers are still working.
Tacos.
Is anybody talking? No, somebody is talking, but I can't hear you. Damn it. What are you doing to me, speakers?
Yo, you really can't hear?
All right, hold on, guys. Sorry. It's too exciting. All right, try again.
Canada.
There we go. Canada. That's
It
so
started
awesome.
with
All right.
tacos.
What's that? Somebody said tacos? All right, I'm not sure what's happening. Let's just move on. So in this picture, can somebody just tell me, now this is where things get, this is very important. All right, this is where we lay the groundwork for some stuff that's going to go through calculus. When I ask you something like, where is this decreasing? The answer will be in terms of this, the x. In this case, it's time, right? So at what times was this p function decreasing? What do you guys think? When is this decreasing?
From
Sorry?
-infinity to -1.
I like it. So one interval, so decreasing would be from -infinity to 1. Why does that make sense? Because what's happening right at 1? What's the function doing right at 1? What would you call this?
Rising.
It's stable.
What? I'm sorry, say it. I can't really. Variety, is that what you said? And then unstable? So this is a turning point. Right? I was wondering if anybody would say like a vertex. It's not really a vertex because it's not a parabola. But is that cool? You call this a turning point? Doesn't that make sense? So it's turning from falling to increasing. So if this is my company, this is my profit over time, I'm sad. I'm sad, but I'm feeling better. I'm good. I'm feeling good. Oh shit. And then, oh yeah. Right. That's basically the emotional description of that company's journey. Let me see. All right, go ahead, buddy. Let's see. Okay. Where else is it decreasing? Is it decreasing somewhere else?
3 to 4.
3 to 4. I love it. Because that's another turning point, and that's another turning point, right? All right. So where's it increasing? It must be increasing everywhere else then, right?
1 to 3.
1 to 3.
And 4 to infinity.
4 to infinity. I like it. That's easy, right? Isn't that easy? Not bad, right? Okay. Now, can somebody tell me this? What is the local? Let me see how you guys like these words. The local minimum.
-1.
Yes, kick ass. All right, I got excited. So when I ask you, where does something happen? Like, where is it decreasing, increasing? That's the x-axis. In this case, the time, right? But that's the x-axis basically, right? When I ask you what is happening there, like the minimum value, the maximum value, what is happening? That is the y-axis. That's, in this case, the p, but you get my idea. Is there another local minimum? Let me put local minimum value just to make this really clear.
1.
Say again, sorry.
1.
Not 1, no.
0.8.
That's neat. Where are you getting 0.8 from? Oh, I see. Is it still coming from this? Would you
No.
guys say that this is a minimum? Is that the top of a hill or the bottom of a valley right there?
The top, that would be the local maximum.
That would be a local maximum. Get out of there. Local max. So that word local means just in the area around it. Isn't that the top dog in this little town? Of course, this guy's laughing at him and this guy's laughing at him, but he doesn't know. He lives in this little tiny town. So local means exactly what it sounds like it means. Close to that. That is the highest point. So that is a local maximum. And yes, I would say that's about 0.8 maybe, right? Now come back up here. Is there another local min?
0.5.
0.5. Kick ass. I like it. What's the absolute min?
-1.
That, yes, because that's the absolute lowest value. That's the absolute min value. Is there an absolute max value?
No.
No, because it goes forever up. I love it. All right, it's not bad, right? Those words pretty much mean what they sound like they should mean, which is nice. Absolute means the function never gets bigger or smaller than that thing. Local means, yeah, it could get bigger somewhere else, but locally, what's the biggest? Locally, what's the smallest, right? Does that make sense? Maybe.
Yes.
I like it. And it makes sense also that all of these values actually happen at the turning points, right? Every turning point that we've identified is more than likely going to be min or a max of some kind. Okay, I like it. That pretty much summarizes the rest of section 3.3, if I remember correctly. Let me make sure I'm not leaving anything out. No, that's it. Let's try a different graph. Let's see. Shit, hopefully you guys were ready for me to do that. I'm sorry. That's boring. Oh yeah, I'll show you how to do it in the calculator too. That's boring. Boring. There, I give the answer. Here we go. What are they asking for here? Yeah, okay. Is there an absolute maximum value?
Yes.
There's two.
Let me make sure about something. Hold on. Blah, blah. They don't really say, do they? Yeah, okay. They're not really making it clear. They really should say absolute maximum value, and that tells you it's the output. So I'm sorry, say it again. What's the absolute maximum value? Is there an absolute maximum value?
16.
16. Does it happen more than once?
Yes.
Yes, and that's fine. It still exists. It's still 16. It never gets higher than 16. It doesn't matter if it happens an infinite number of times. That is the ceiling. What's the absolute min value?
About -10.
Yeah, right down there. It looks to be right in the middle, so I agree with you. -10. I like it. Now, if I said this, where does the absolute min value occur? Can somebody tell me that answer? Kick ass at x = 3. Where is x-axis? What or value, right, is the y-axis? Okay, I like it. I like it. I like it. And of course, what's the local min? That's not an absolute min.
0.
Yes, 0, and it occurs at 0. So you can't go wrong there. I like it. Kick ass. Not hard, right? That's nice. This is nice. You're like, let the whole class be like this, Jeff. No, sorry, it's not. But at least right now you can enjoy this. This is not difficult, this section right here. So please enjoy this section. And that's it. That's the end of that section. So, shoot. What time is it? Okay. Oh, good. We got a little bit of time. I do want to talk a little tiny bit about the next. I wanted to talk more about this section, but too bad, Jeff. This section is relatively easy, and I want to show you. We've already done this section, to be honest. Let me see if you guys can do this. All right, I really want this to just make sense. If you understand functions, you should understand this pretty quickly. If I say f of x is 2x minus x squared, and g of x is x plus 1 over 3, can somebody tell me what is, you could do it, Jeff. What is, yeah, sure, g of f of -1? Algebra has prepared you for this moment. When you have something you have to simplify, where do you start? In an algebraic expression, you start in the very inside, don't you? Don't you find the innermost? All right. So I can't evaluate g at this until I know what the hell this is. This is g of number I don't know yet. So you have to figure out what this is first. What is f of -1?
-3.
Right? If you put -1 in, you get -3. Is that cool? And now I can do g of -3. Get in there. So that's not that far away from what we've already been doing, right? Yeah, I mean that's it. That's remarkably, that's all it is. They get a little bit into, oops, where did I put you at? They get a little bit into the domain and how it changes a bit. Let's talk about that a little bit and then we'll call it a day. Let me make sure I'm not forgetting anything. Oh yeah, there's all that too. What do you guys think of using the same functions? What do you guys think of this here? You can do it, Jeff. Sure. That's really not hard, right? You can't subtract these two until you know what the hell that is and what the hell that is, right? So you could do this. You could just say, okay, f of 2, do that work. G of -7, do that work, and then throw those numbers in, right? If you need to. You could do all that on the side. So f of 2 is actually 0, right? And what's g of -7?
2. -2.
Okay. So then this is 0 minus -2. So then you get 2. Whoop-de-doo, right? Not hard, correct? This section really should not be difficult, thankfully. Okay. Is that enough for today? Maybe. Is there anything else I want to say there? Except for the domain stuff. Blah, 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 blah. No, I'm not too concerned about that. Oh, no. Oh, here's one little thing. Let me talk about this. I always forget to talk about this. This is perfect. This will be the last thing we talk about. So it's like an XY table with two different Ys, right? Let me see if I can make up my own problem here. Let's see. What would G of F of 3 be? This one's funny because people think it's hard, but the answers are there. I don't even, did they tell me what the functions are? No. Why do I not give a shit? Because I know what the answers are. What's f of 3? Can somebody see that?
It's 2.
2.
No. Or hopefully it's not because I can't write well. I don't know what's happening.
It's 3.
F of 3 is 3, right? G of 3 is 2. Do you guys, is everybody with me? Let's make sure we can read this table.
Yeah.
G of 1 is 3. F of 4 is 1. Okay. So F of 3 is 3. And what's G of 3? Or did you guys go to the end? Is that what it was? Did you guys get ahead of me? G of 3 is 2. Is that cool? G evaluated at 3 is 2. So now let me try this. What is F of G of, I don't know, Jeff. Well, you have to do that one. Yeah, you can do that one. What is F of G of 1? So what's G of 1?
3.
3. And what's F of 3?
3.
3. There you go. Done. Yay. All right, and that's plenty. That's enough. All right, guys. So let's all hope that was our only zoo bombing ever. If so, that was very mild. But I do have security measures in case something like that happens on a bigger scale. That was just one person, so I could get them. Some of my colleagues have had like 5 or 6 people at once. And this is before Zoom had the security button you can just push to lock everything down. So I feel bad for them. It was not good. There was really, really horrible things that happened. This was whatever. It's like a prank phone call. Who cares? Is your refrigerator running? Oh, shit. All right, guys. Is that how that goes? Make like a tree and split. All right. So back to the future reference. All right, guys, let me know. Oh, geez, that's a hard one, man. Let me know if you have any questions, if you want to hang out. Oh, dude, that is not an easy question. I mean, I love the character Cardio. Was that his name? You know what I'm talking about? The little heart dude. That whole series was hilarious because I think it was, and of course, yeah, give me a break. Would you, hey, Fan, you want me to cook your apple pie? I love it.
Bye.
Oh, okay. So, guys, bye, guys. So if somebody's asking a question about what does a grade of incomplete mean? So everybody's able to see the feedback. There's a video up there for how to access the feedback. So if I gave you a grade of incomplete, you can look at the homework to see exactly what was wrong. Incomplete doesn't necessarily mean that you left some undone. It just means you made too many mistakes and I want you to correct them, maybe. Or it could mean that you need to finish it. Is that cool?
So if we correct them and resubmit it,
You could get back up to full credit.
okay.
Yeah. And all that's in the syllabus. So if you want to look at that part.
Professor,
Yes.
I have the same question. Like you mark my homework incomplete, and I resubmit, and you don't give me any grade yet.
Because
gonna
I appreciate your thought that I'm super person. I'm not. I'm just a single person trying to grade the new homework. I have not graded any corrections because there's a lot of new homework.
Okay. Well, I was
So,
thought you will not
corrections.
give me the grade.
Say again, sorry.
I was thought you will not give me a grade about this.
Oh, no. Yeah, no, I'm just one guy doing what I can. So corrections, I don't know. I'm just going to grade those if and when I get time. My focus is always on the new homework. Yeah. Yep.
So if
thank you so
we correct our mistakes and turn it back in, then we can get back up to full credit or?
Yep.
Okay, cool.
Even if I say redo, which means you left way too many blank or you missed way too many, you could still get back up to full credit. Because I always want people to understand that there's motivation to do it and to understand it, right? If I just gave you a grade and said, that's just what it is, then you'd have no motivation to go back and try it again.
I have a question on that.
Yes.
How many times are we able to redo it or do it again?
You can correct everything except the final once. Does that make sense? You can correct section 1.1. You can correct section 2.1. You can correct section 3.1. You can correct section 3.2, 3.3. You can correct everything once. So this is not English class. You don't get a first draft, second draft, third draft corrections.
So when is the due to resubmit it? Like when you say incomplete, so when is the due again?
Homework corrections are due by the day of the final. If only I would have written all this stuff down on like a thing called a syllabus, man. That would have made it great. I know. I'm just feisty today, man. But I made a whole video on the syllabus too. If you want to just sit back and listen to me talk about it, that'll work too. But I don't want you to feel bad. You can ask me anything, but look through the syllabus. It's a little important. Okay. How's everybody else? You guys good? All right, guys. I'm headed out. I don't see any more questions.
I have a quick question.
Oh, yes.
So for my homework, I saw that you did some corrections for it, but you didn't give me a grade. So I wasn't sure if it was correct or incomplete or anything.
I'm not sure what you're talking about. Let me see. Let me look you up. Which section are we talking about? You mean you turned in corrections?
Section 3.1. No, it was the first time I submitted the homework. There's just no, like, it doesn't say like a okay or a correct or anything.
Oh, I started looking at it and I haven't finished, I think.
Oh, okay. I just want to make sure. Okay, cool.
Yeah, that's the bad part about that. I've been grading all day. And to be honest, I think I started grading yours and then totally got off track. Well, I kind of started grading the chapter 3s, but then I had a whole bunch of chapter 1s and 2s come in. And that's got to be my immediate concern. So I stopped grading your chapter 3.
Okay. That just makes sense. I just wanted to make sure.
Yeah, okay. So don't worry. Until there's a thing in there, don't worry about it.
Thank you.
And Kurt, I don't know what you mean. Can you tell me what section we're talking about so I can see what's going on? Kurt?
Section 3.1.
Oh, not Faye. You're good.
Okay, I'm good.
Somebody
Thank
else.
you.
Kurt. Yeah. 1-1. Okay, let me look you up here. Kurt, Milana. There you are. I see plenty of markings on yours. So do you know how to access the feedback? Do you know how to? I don't understand. So here, I think I even started playing this in class the other day. See this right here? How to view the notes. It's one of the announcements. And then you can just play this thing. It's like 1.5 minutes long, I think. Yeah, even less than that. And it very, very quick video. Right anyway, now. You can watch that. Is that cool? You can watch that video and it shows you how to access the feedback. It's just you have to click the right thing. Is that all right? You don't have to download it. No, it's so here. I want to show you. Let me speed myself up. The notes that I put on your turned in assignments. If you go to grades and you click on anything that I graded, don't worry about this. This is like a click on something I've graded. Don't click on this. Click on view feedback. And then you will be able to see. I will write notes here for you. I will have markings through things that are wrong. I have question marks. I'll have all kinds of stuff. And now download the. Let me shut myself up. So then you can make corrections. Where am I? Okay, don't worry. I'm doing this in my math 136. Be quiet. Be quiet, old Jeff. Sometimes if your connection's not the greatest or Canvas is having an issue, it has trouble loading the document. Do you know what I mean? So in that case, you could try to download it. Sometimes the download works and the viewer doesn't work. I don't know. So if it's just not opening anything, try to download it. Does that make sense? Okay. You're welcome. Shamahashi, are you good? Everybody good? I'm out of here. I don't see any more questions. I'm gone.